So I've probably worked more with mango for fresh cut than any other commodity. So what I'm going to go through in the next 25 minutes or so, if I keep on time, is a series of projects that we've done with fresh cut mango, answering different questions that have come up. A lot of this was from a PhD student, Sharon D., who did her whole PhD on fresh cut mango, and then a couple of projects funded by the National Mango Board, which is interested in fresh cut as a way to increase consumption of mango. So the first of these is quality of fresh cut mango prepared from hot water and non-hot water treated fruit. If anyone here works with mango, this is something that comes up repeatedly. The industry never has really liked the hot water treatment that's required for insect quarantine for mangoes to be exported to the United States, and they think that it ruins the quality of the fruit. So this was one of the things we did. When the mangoes come through the system, as they come into the packing house, one of the first things that happens before anything else is they get dipped into these huge hot water tanks. And the system, the procedure they follow has to be very specific. The fruit have to be at least 70-degree pulp temperature before they go into the water. They have to be submerged at least 4 inches. The water is 115 degrees Fahrenheit. They're submerged for 65 to 110 minutes, depending on the size of the fruit. Larger fruit have to remain submerged longer. Then when they come out, they may or may not be hydrocooled to more quickly cool them. That was, interestingly, something that the Mexican mango growers came up with independently. They found that they reduced hot water injury by using hydrocooling. Then they started finding some mangoes with live fruit fly larvae in them because the cooling was actually offsetting the hot water treatment and killing the insect. So now they have to go through a process where the fruit have to either go through a longer hot water treatment if you want to quickly cool them, or they have to rest for a while before you cool them. So it's very complicated. So we looked at that, and basically I'm just going to cut to the chase on all of these projects. Overall, the results suggest that the hot water quarantine treatment doesn't have a significant effect on the quality of fresh cut mango slices, as long as the fruit are at the proper ripeness stage to start with and stored at 5 degrees. So what has really been the explanation for this problem with the hot water treatment is that the method was developed using fully mature, meaning partially ripe mangoes. And for export, they're harvesting the mangoes earlier, and the less mature the fruit are, or the less ripe they are, the more sensitive they are to hot water. So the quality problems associated with hot water quarantine treatment are probably related to treatment of immature fruit. So that's the real issue. So immature mangoes are more susceptible to hot water injury, and just to add insult to injury, no pun intended, they're also more sensitive to chilling injury, so they get a double whammy because the farther the distance for shipping for export, the lower the temperature they tend to use during shipment. So they start with the less mature fruit, they get hot water injury, and then they put them at low temperatures and they get chilling injury as well. So, and both of those injuries reduce the sensory quality of mangoes, especially aroma. That's something that's a symptom of stress in mangoes, is that you get inhibition of aroma volatile synthesis. Consequently, that's where the idea has come from, that this ruins the taste of the fruit, the flavor of the fruit, I should say. Okay, next is, what is the optimal ripeness stage for processing fresh cut mangoes? So we're looking for a way to select an optimal ripeness stage based on appearance combined with sensory and compositional quality, so that you'd have the best quality fresh cut product. So we used Kent mango, which is a variety that the processors tend to like. It has nice textural quality, tastes good, big fruit with a good yield. in terms of the flesh versus the waste part. And so what we did was we were looking for fruit sort of in this range of stage 3, 4 on a 1 to 5 scale from before ripening or the beginning of ripening through. This is pretty much stage 5 is where a normal person would really eat a mango, but you have to have some shelf life after the processing as well. So there were visual, subjective evaluations. Stage A, B, and C are different ripeness stages at the beginning of shelf life, with A being the least mature and C the most mature. And did this kind of principal components analysis that shows you how the quality is, different aspects of the quality are changing from day to day. And you can see what the big issues were. We had desiccation, we had edge tissue damage, we had overall color or appearance of the fruit. And you can see here with this one that the edge tissue damage and spoilage or breakdown of the tissue what was really limiting the shelf life. And so what we came down to is using firmness, initial firmness of the whole fruit as an indicator. Essentially about a 6-pound mango or so is about the right stage to be cutting them at. It's not as ripe as you might normally want to eat it yourself, but if you go lower than that, a fully ripe mango is like maybe 2 pounds pressure with the normal 8-millimeter probe measurement, but around 6 is probably about the best compromise between fruit that's ripe enough to be good quality and also have on the order of 10 days shelf life. We also looked at chilling injury in fresh cut mangoes, and this relates to one of the things I brought up in my talk yesterday, how there was this question about whether we had to concern ourselves with chilling injury with fresh cut tropical and subtropical products because you need to store them at a very low temperature as fresh cut products. Was that going to be causing problems with chilling injury? And so as I said, we did this evaluation. We looked at whole and fresh cut fruit at 5 and 12.5 degrees C, which is 41 and 55 Fahrenheit. And the most striking difference between the two storage temperatures was the appearance of the slices, and to a lesser extent the composition. Basically, no one's going to store mangoes, fresh cut mangoes at 55 degrees, but they don't have the shelf life anyway. They only last like 1 or 2 days at that temperature. But as a control for our experiments, we were doing that. What we found actually was that there was no visual chilling injury symptoms within the time frame that you would store a fresh cut product, either in the fresh cut or the whole fruit. We did see reduced ascorbic acid content and some increased softening at 5 degrees, which is not normal because usually greater softening at warmer temperatures because it's ripening related. But in this case, it seemed to appear that there was some chilling stress, which of course we know there is chilling stress. And really it's a matter of the exposure time not typically being long enough at the chilling temperature to make it the primary issue for limiting the shelf life of a fresh cut product, and that's what we found here too. So the fresh cut mangoes were better stored at 5 than 12 because the chilling injury at 5, if at all, was less significant than the natural super fast deterioration at 12 degrees. Another thing that is an issue with fresh cut mangoes is if the peel is not removed to a sufficient depth, you can have quite a bit of surface browning. And if they're not smoothly peeled, you can see all the ridges where they're not peeled quite as deep would turn brown and be darker. So we looked at this in terms of the PPO, polyphenol oxidase, the enzyme that causes the oxidative browning, and the concentration of the phenolic substances that are the substrate for browning. And what we actually did was we used a test that was being used here for many years at UC Davis to evaluate bruising potential of stone fruit, using catechol to measure the PPO activity, and then another quick test like this for measuring the presence of phenolics. It was developed by Alec Cordes, who was a chemist working with Adel Cater, and Gordon Mitchell, who was actually Beth Mitchum's predecessor in the post-harvest group, evaluated hundreds of stone fruit cultivars using this method. So this is showing the development of the browning over 10 minutes time to different depths in the tissue. And actually it showed that the PPO activity develops more in the deeper tissue than that tissue near the peel that I was talking about before. So the potential for the browning is actually greater at the deeper tissue. And there's like a demarcation also between the 4.5 and the 6 millimeter depth, where as you go to the deeper depths, the change in color is much faster, which is the measure of the enzyme activity. And then this is showing the presence of the polyphenols, the compounds that are actually the brown color that develop over time after the cutting as well. So again, this is 10 minutes time period and down to 12 millimeters depth in this point, and we see that it's a little more uniform, that you get the phenolics being produced throughout the tissue more or less, but still more in the deeper tissue. And there's not that demarcation like there was with the enzyme activity. So there's potential for browning in fresh cut mangoes, and what we have found in doing our lab tests is wherever there's any damage to the tissue, quite often the way the mangoes are being peeled, they get set vertically on a table and the person peels this way. So you can get some damage to the tissue on the tip. And if part of that is retained in the slices or the chunks, that damaged tissue will turn brown and become the limiting factor in the shelf life of the product. Modified atmosphere packaging for fresh cut mango. So we've talked about MAP extensively already, and this was looking into the potential benefit for mangoes. We did preliminary CA work. This is sort of how you develop this kind of thing for a product where it's unknown. You use controlled atmospheres to test different combinations of oxygen and CO2, usually first oxygen by itself and CO2 by itself, and then the best of those two get combined, and you see if there's a synergistic effect between the two. So we initially looked at 0, 2.5, 5, 7.5, 21 kPa oxygen, which is essentially equivalent to percent. Kilopascals is almost the same as percent. And we tested a range of elevated CO2 as well, 0, 10, 15, or 20, because the whole fruit are actually quite tolerant of CO2, which, like I said the other day, is not true of every fruit and vegetable, but mangoes are quite tolerant. And then we looked for the best combination. And so we came up with the best combination was 2.5% oxygen, 10% CO2, but it only had gave a slight increase in the shelf life of maybe 1 or 2 days. So not a whole lot of benefit from it, something, but not very much. It's something where you'd have to determine whether it's worth the expense of having a modified atmosphere package designed. We looked also at adding calcium ascorbate, 2% calcium ascorbate dip plus 1% citric acid. Lowering the pH is one of the very common methods that's used to inhibit PPO activity. So this is all related to antioxidant, ascorbic acid, and the citric acid to lower the pH of the tissue, both to reduce browning, and the calcium, of course, as I mentioned before, as a firming agent. So So that also had a small effect of 1 or 2 days extension in shelf life. And so those two together, the MAP and the antioxidant calcium treatment, led to less spoilage, 2 to 4 day increase in shelf life, which gave us a total of about 10 to 12 days, which is in the ballpark of what you would want. But with that extended shelf life, even though the appearance is good, we found less characteristic mango aroma, a little bit less fresh appearance because of some desiccation. So maybe we didn't have a properly designed map like Jeff Brandenburg would make for you, but we did see some surface desiccation that actually became the appearance factor that limited shelf life. So, on to the projects that the Mango Board has funded. As I mentioned, the Mango Board, as a commodity board, its reason for existence is to increase consumption of its commodity. And so I've been told that only something on the order of 50% of the people in the United States have ever tasted a mango. So the Mango Board thinks that fresh cut might be the entree, that someone who hasn't ever tried a mango before, doesn't know how to peel it, doesn't know how to eat it, they might try fresh cut. But the quality of the product that's available is largely not very good because they're being prepared too soon, I think, not ripe enough, they're not ready to eat. So the first project they funded was a joint project with the University of Florida, UC Davis, and the USDA lab in Fort Pierce, Florida, and we all, through the course of a year, took weekly or bi-weekly samples from local stores. So we had 3 chains represented in each location, so there's multiple stores in each location. And so we caught the mangoes coming from all of the different countries. So let's say we start with Mexico around March, going through maybe August, and then you get Brazil for a month or a month and a half, then you get Ecuador, then you get Peru, and then you get Mexico again. Those are the primary countries. So we were just monitoring and evaluating the quality through the year, what consumers would get from local supermarkets. And primarily assessing them with sensory evaluation, but also measuring their color and firmness and soluble solids content and titratable acidity. So we also, at the same time, Carlos Crisosto, who was the lead here in Davis, and we interviewed people in the processing companies, finding out, and the retailers as well, why are they processing the fruit when it's unripe? And we're told basically that it's a matter of convenience in processing and longer shelf life. And so they're doing that, but I can't believe the consumers are happy with that. So this is the kind of thing. These are pictures of actual samples that we bought at stores, and we literally had fruit that were completely unripe, and the texture of a carrot stick, like inedible. And we went through and did extensive evaluations. This is just one set for one retailer, 2 different stores in Florida, and all of the different evaluations given a numerical value. The possible maximum score is 49. And so all throughout the year, it's mostly around 30 out of 49. Yes, question, yes? Yeah. So technically it's a hit and miss. Usually there's a market for green mangoes, but I don't think that's for people who are going to buy fresh cut. I mean, after Mexico sort of took away most of the Florida mango business, they started growing for niche markets, and one of them is green mangoes that people make chutney out of it and other things like that. But in this case, I don't think that is that's preferable by very many people. So just as sort of a bottom line on this project, Ann Plotto, who was the lead at the USDA lab part of this, she did this word association thing. I don't guess there's a software program that does this for you. And you can see the bigger the word is, the more emphasis, the more responses there were in the taste panel testing. So I mean, you see sour, 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 starchy, off flavor, green, and it's just unripe. It wasn't very good. So we reported that to the Mango board, both that we thought that the quality was really not acceptable and the reasons why. And so they funded a follow-up project because we said it should be possible to process riper mangoes and get at least 10 days shelf life. We're hearing from a lot of retailers in the range of 10 to 14 days is what they want, which to me is really unwarranted, because having gone through the system that's being followed, it's like the mangoes are being processed today, they're sent to the retailer's DC the next day, and from there they're at the stores like a day or two later, and nothing gets left out on display for very long, right? So why 14 days when maybe 5 or 6 days is really all you need? But anyway, we tried to determine what's the ripest stage you can process mangoes and get at least 10 days shelf life. That was the goal of this research project. So we followed the same procedure that Sharon D. had used in her earlier project, where she did initial firmness as the non-destructive firmness as the way to select the different stages of mangoes. And so you get a lot of mangoes and they vary in firmness, and so you can select smaller groups that are within a firmness range. And doing that, we had the same A, B, and C that you saw before. This is actually what it referred to in terms of newtons, which is the SI unit for firmness. So 30 N, like I said before, 6 pounds, that's about what 30 N, 30 newtons corresponds to. So we did the same type of evaluations, and showing the mango slices do not change in texture very much during storage. So that's not really a limiting factor of the fresh cut product. So you can see we looked at different varieties from different places during the course of the project over a year. So Kent from Peru, Kent from Mexico, Tommy Atkins from Nicaragua, and you all see that in general they're the same. We did some looking at non-destructive firmness testing. This near-infrared device is something that you can do non-destructive external measurements of the fruit, and we tried to correlate that with firmness. And actually, it's only an R-squared value of 0.46, but that's pretty significant, but there is a lot of variation. So we're following up on that to see if we can improve that. It depends on what you choose from the output of the instrument to correlate with what you're interested in. So we need more data, and we've been doing that. Actually, there's a project that's been going on this past mango season in Florida. It's not fresh cut, but we've been evaluating mango cultivars for the Mango board for their potential as new export varieties, and we've been continuing to collect this NIR data. So as I mentioned, the firmness changes are not really very great. The sensory evaluation included the hue, which is the shade of color, the cut edge sharpness, because it's those edges where you start to see the tissue breakdown, as I mentioned before. The moistness in terms of the appearance of the slices, which is sort of how we perceive whether they're fresh or not. And you can see how each of those bars in each grouping are the 3 maturity stages or ripeness stages that they're cut at. So this is showing that as you get to the firmer fruit, you have greater cut edge sharpness, but less orange-yellow color, less moistness. So there's a trade-off between the two, between the firmness stages for what's going to be better and what's not going to be better in terms of the sensory. So you have less flesh browning with the 35N or firmest fruit. The translucency is sometimes greater with the 25N fruit, so that's the water soaking or translucency I was talking about. That's related to senescence, so that's greater with the softer fruit and tends to limit the shelf life. The firmness is higher with the 35N fruit, but the juiciness is lower. The sweetness is higher with the 25N fruit and the sourness lower. And all this varied quite a bit in terms of, so you have to determine which is best for any given cultivar, and it changes with storage time as well. So basically, we found that you could get on the order of 9-10 days shelf life, even with the softest fruit. So that's good news. Then we also looked at coatings. This is sort of a specialty of Liz Baldwin at the USDA lab, who we were working with on this, Ann and Plato and Liz Baldwin. So they looked at different coatings as supplement to the selection of the initial firmness stage. And actually you can see here that we got quite good response in terms of flesh browning. So the first one is the control in each case, and you can see there's quite a bit more browning in the control compared to all of the different treatments we tried. And this is what they looked like. More effect. This is just another variety from another source, and what those fruit looked like. And then we looked at MAP, and again found very minor effects from MAP. Even less so than Sharon had found earlier. So uniform ripeness is the most challenging aspect when processing mangoes, number one. It would be ideal if you could select individual fruit to process. But what I mostly saw visiting the processors is whatever gets brought out, every single fruit gets peeled and cut, even if it's not even beginning to ripen, which I think is a big part of the problem. Conditioning the fruit in ripening chambers is a viable solution. You can ripen these fruit to the proper ripeness stage. It could be done in-house. It could be specified from your supplier that you want fruit delivered at a certain firmness, for example. We didn't get good results from MAP. It didn't seem to have a great effect. 30 to 35N gives about 10 days shelf life with better tasting fruit than found commercially. So it's not the 14 days, but 10 days I think people could live with. Coating the fruit actually improved the fruit quality quite a lot, mostly due to the antioxidants. And then I'm just going to finish with this last slide, just so you don't think we're the only people who do any fresh cut mango work. This is results actually from Diane Barrett and Beth Mitchum, and a graduate student they were working with whose name is there and I can't really pronounce it. Yeah, there we go. And so they did similar work looking at the proper maturity for processing mangoes for fresh cut, and the results were very similar in terms of the firmness being a good indicator, and about the same firmness as we found as well. So that's what I've got on fresh cut mango. Okay.